Oh, yes.
Where's Rachel? Where is she? Where'd you... Harvey? Where did you put her? Where did Harvey put Rachel? Hello. Hello. You're watching Nerdish. I lost my shoe. You gotta put your shoe back on. Go with it. Very good. What are we doing here? Well, we do SAT, ACT prep for everyone. Yes, and the question is not where is Rachel, but when. 8 to 9:30 p.m. That's when Rachel is. Tuesday, Wednesday, and Thursday. Watch it. Just see what it's like. It's for free. All week long. You can ask us questions like where's Rachel and what you do with Rachel and where is Harvey Dent. They're both studying for the SAT. It's a very important test if you want to go to college or university. Nice. I should have said university first because it rhymes. Oh, that's Catwoman. That's okay. I think we know Catwoman because we're Batmen. Let's do a problem. Yeah. We did exponents last time. What should we do? Let's factor a quadratic. Okay. Man, when it comes to education, I'm an addict. Oh my god, but not that kind of addict. No, just a quadratic addict. I hope this is factorable. Oh, it's gonna be factorable. Add 6. Okay. 6 is for Rachel. Alright. Let's take out a 2. Let's make it equal to 0. That's a good idea. Okay. So let's factor out 2. X squared minus 2. How much time do we have before Rachel explodes? Ask Harvey. Harvey. Multiply to positive 3, add to negative 2. I don't think that's possible. Oh, shoot. That's okay. Sometimes you can't factor quadratics. And sometimes you can't save Rachel. I was about to say that. I'm so sorry. No, it's good. It shows that we're tight bonded. Like Tight Bond. Original wood glue. It has a tight bond. Like me and Levi.
Hello, Hono. And yes, Butterveda27, you're first. Wait, you guys, we have that intro all the time. We used to have a different intro, and then Hendrick27.
Hendrick?
Wait, now you guys see the intro? Go put on your shirt.
I wanted...
Well,
I want to have this. I want to
you
be
can
part
have the
of this
conversation when you have the shirt on. You can't do it wearing that. Sorry, guys. You see what I have to deal with. Anyway, yeah, no, that's our intro. You guys like it? Yeah, it's a great sweater, I know, but Levi is part of Nerdish, so he's got to put on his Nerdish shirt.
Yeah, that's my other company, my other tutoring company.
Oh, sure. Yeah,
it's called Salvador Dalai Lama Tutoring.
That's pretty good, actually.
Yeah.
Did you? That's
no,
what it is.
I did not just come up with
That's
that
what
right
the
now.
sweater is.
Yeah.
Salvador Dali.
But it was also for a French house on campus because it was La Maison.
Oh.
Like Lamazon.
Yeah, that's right.
Like the zone.
Like
of
Amazon, Jeff Bezos.
Like that, but not at all.
Richest man in the history of the world.
Hono, you have to put questions in the Discord immediately.
You guys need to watch our intros. They're fun. They're really fun. You know, we don't do them for nothing. We do them for you.
Wait.
What?
Do they see us right now?
Yeah. Why would they see us?
I don't know. Nobody's responding.
They were just doing a bunch of things.
Were they?
Yeah.
To us, or were they saying...
He says, I love that sweater. He saw your sweater.
Oh. Hono, you do have questions.
Hono, you always have questions.
You always have questions.
You literally always have questions.
Every single time.
Yes.
Butter, also, you need to ask some questions, too. Don't think you got out of it. You just joined the Discord, so you have to ask some questions in the Discord.
Yep. Yes, they see. Good. Okay. Otherwise, we're going to be forced to put some math questions on the board and start doing them.
Yeah.
And I know
which
that
is very boring.
You don't want that. We don't want that. Actually, I kind of want that.
No, you don't.
Well, I little bit.
Is it the same overlay? Because all of those questions are done.
No, they're not.
I did all of them after you left.
You finished the rest of them?
Yeah, all of them.
No, you didn't. No, you did not.
Who was asked?
Did not.
No, I know, but like we're pretty much done, and they were all pretty doable, and because nobody seemed to care to watch them
Well,
necessarily.
you know, that's kind of fun. Let's go to the hard stuff again.
Oh.
Why don't you like
Oh,
this?
Oh.
All right, hold on. Let's find a good one here.
Does
All right.
anybody have any questions that they want to ask and they want us to answer? Butter, I know you see us. I want you to ask us questions. We're very hungry.
Hey.
Ask questions about the viscosity of birds' weenus.
Hey, number
here.
7 looked kind of fun.
Can't really see it. It's very small. I can't stick around today because I realized the AP physics test is in 12 days, so I'm going to be studying that. But have a nice stream. Thank you.
Who was that?
That was Butter. Oh, yes. Great. Okay, Kevin. Kevin asked a question yesterday. Did you put it on Discord? Did you put it on Discord? I forget if it was on Discord. I think it was on Discord.
Was it on Discord?
I'm going to tell you in a moment. I was clearly demonstrating my lack of
Alan.
assuredness.
Is that Alan?
No. No, it was this one. Yeah.
Oh.
Papoose.
Oh, okay.
Yeah. You want to do that one? I
Sure.
can look at the other one. I don't know when that other one was put there.
Sure. That was just now.
Oh.
All right, Kevin Lart. Kevin Lart. It's like hard, but it's Lart.
Right. It's definitely like that.
Okay, and yeah, Hono, you got questions about probability? You know, go ahead and just ask
I'll
us.
look if
Oh,
it's-
put this up on the monitor.
Oh, yeah.
That's the whole point.
It's going to take me a hot sec.
That is the whole
It
point.
is the entire point.
Bum bum ba da dum bum ba da dum bum ba da dum bum. Da 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 da. I just watched the first episode of the first season. I've watched everything. Don't worry, guys. But Eric TLT.
Eric, what's up?
You'd need some time management techniques, don't you? We're cropping this. Give us a second.
Always does.
Just give us a second, guys. Seriously, calm down. We're cropping this. We're cropping it. It's going to be great. And then Levi's going to move it up to the corner. There we go. Up to the corner. Got it. All right. Well, okay, fine.
Has the same asymptotes. You got it, right?
Well, no, hold on. Good. They got to read it. Okay, good. That's good right there.
Yeah? Happy?
Make it a little bit smaller.
You make it a little smaller. That's mine.
All right, good. All right.
We're very technologically savvy.
Yeah, savvy. Great. Which of the following has the same asymptotes as that equation? All right, let's get into this. That is a conics equation. And conics, you got a bunch of different kinds of shapes you can have with conics. You got circles, you got ellipses, you got parabolas, and you got hyperbolas. All right? This is a hyperbola right here. Okay? So, real quick, your different conics equations. I'm going to guess since it's literally everything opposite. You know what, Eric TLT? I'm going to guess you because you're literally everything opposite. How does that feel? That's what that question feels like now that you said that. All right. Circles look like this. Ellipses look like this. Parabolas, there is a conics equation for parabolas, but normally they put it in standard form of a quadratic, so don't worry about that. And then we have hyperbolas. Or as I like to call them, hyperbolas. All right. What these are, x squared over a squared. They look like they're about to be an ellipse, but then it's subtraction instead. All right? That is the equation of a hyperbola. Okay, so whenever you see the minus inside the parentheses, that always gives you the center, okay? That gives you the center for all of these different kinds of conics equations. So let's draw this thing out. Is this on SAT? This is an ACT question. But yes, they do ask conics questions on the ACT. Do they ask conics questions on the SAT?
No.
They don't? Wait, hold on. They ask about circles and ellipses.
Circles, yeah. I don't think ellipses on the SAT.
Yeah, okay, circles definitely on the SAT. Maybe not this stuff. All right, so we have x plus 2 and y minus 3, which means our center is going to be -2, 3. -2, 1, 2, 3. That is our center right there, okay? Now our a squared value is 16. Our b squared value is 25. Let's talk about what that means here, okay? Our a value would be 4, and our b value would be 5. This is similar to ellipses, which is this kind of is like your x radius and your y radius, but it's not really a radius per se. I'll show you what this is going to be. Our a value is 4, which means we're going to go 4 units to the left and right. All right, so we got 1, 2, 3, 4. All right, and then 1, 2, 3, 4. Our b value is 5, so we're going to go up and down by 5. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, up here. All right, this right here we make into a box. We make into a box with dotted lines. It's got these points we just put down as the sides, the center, the midpoints of these sides of this box. And I'm going to erase some to get some space. Okay, the next thing. Hyperbolas can look two ways. They can either look like this, or they can look like this. And they go on forever, okay?
Are they always green, my lord?
Yes, they're always green. They have diagonal asymptotes that they cannot touch, all right? That's what this question's asking about. The way you know if it's going to be vertical or horizontal is you look at the first term, and that's x, which means horizontal. This is going to be horizontal, okay? Your asymptotes, ready for this? Your asymptotes are going to go through the corners of this box we just made, all right? So they're going to go from here, that way, and then through here, that way and that way. And it is a horizontal, well, it is an x, I guess, x-oriented hyperbola. So it's going to be going left and right, like this. All right, this is a lot if you haven't seen hyperbolas before, okay? Anyway, eventually they will touch since the Earth is not flat. Yes, Eric TLT, that's very good. That's very good.
Eric TLT.
Eric TLT is quite the comedian, I see. Quite the clown with the big red nose and the big funny shoes. What's an asymptote? An asymptote is a line that your function will never touch, but it will get very, very close to it as time goes on. Okay? So, the equations for these dotted lines right here. Let's take a look at the corners that they go through. So, this one goes through, this would be, we went down 5 from 3, so this is -2, and that would be over 4 from -2, which would be -6. So -6, comma, -5. This point up here is 4 units from, okay, this is going to be 2, comma, we're going up 5 from 3, which is 8, 2, comma, 8. Okay, so the asymptote, the equation of the asymptote that relates these, and let me just take a look here. What are the following is the same asymptotes as that? So we get a bunch of, oh, okay, you know what? This is not too bad. We could find the equations of these asymptotes because right now we have 2 points and we could find the other 2 points. However, let's take a look at these different options. So for F, we have the same center, but then we have different a squared and b squared. Why is the line almost perfectly lined up with the mountain thing in the blue in the bottom? What is that? Eric TLT, we can't do it this early. Bring it up again a little bit later. So what's going to happen here is our x for F, that's also going to be a horizontally oriented hyperbola, so it's going to look like this. But your box is going to be differently oriented. It's going to have the same center, but now it's going to be going left and right by 5 and up and down by 4. So you're going to have a different shaped box, which means that your 2 asymptote lines will not be the same. For G, notice that we have y out front now, which means that this is going to be a vertically oriented hyperbola. It's going to be looking like this, okay? As long as we have the same box, we'll have the same 2 asymptotes. That's what we need to find here, okay? So with G, they line up 16 with y and 25 with x, which is the opposite of what we have here up in our actual equation. With h, they make it plus, which means that's going to be an ellipse. And that's not going to be a hyperbola. With j, I think we have a winner. They have the same center, great. They have y first. So j is going to be another vertically oriented one, but the box will be the same because your y value has a b squared value of 25. Your x value has an a squared value of 16, which means you're going to have 4 and then 5, which is exactly the same dimensions as this box right here. And then with k, that is another ellipse, okay? So this one is going to be j, and I understand that that's really difficult. We would probably have to just talk about hyperbolas for a couple minutes for what I just said to make sense. Let me know if you want to just talk about the general form of a hyperbola, because that, if you're not familiar with that, what I just did will be very, very confusing. So let me know. Is that Kevin Lart?
Yes.
Yes, Kevin Lart, let me know if you want me to talk about hyperbolas in general. We have any other questions on the Discord?
Yes.
Oh, we do.
Yeah.
Let's see if Kevin Lart says anything. Bum, bum, ba-da-dum, bum, ba-da-dum. No, I don't mean parabola, Eric TLT. I mean hyperbola. Hyperbola. This is not a... 2 parabolas equal a hyperbola. Kind of. That's what they look like. But a parabola is just one of these. Just one. Kevin Lart, yes as in you want me to talk about hyperbolas for a second, or yes as in, okay, you get it? This always happens. We ask a multiple choice question and we just get yes.
It's not my fault, my lord.
I know. Let's see what Kevin says. Kevin Lart, he's more than Kevin, he's Lart. What does Kevin Lart have to say? Kevin Lart, talk more. Okay, cool.
And then we can do Alan. Who's Alan again?
Alan.
Alan, my lord.
Alan. Steve. Alan.
I'm gonna pull up the other one while you do that, so that I'll be ready for the next question.
Okay. I might need some space here.
Yeah, no, I'm just gonna pull it up and then make it disappear.
Okay. Good thinking.
Oh, I think good. Don't worry.
Yeah, I'm not. I never worry. I literally never worry. I remember learning that as my refresher. Yes, Kevin, you're in the right place for a refresher. This hyperbola refresher is going to be literally so refreshing. It's going to be like you're drinking Sprite on a hot summer's day in the middle of winter, because winter is coming. You know, I forgot how much happened in the first episode of the first season. They established so much.
Yeah, when I watched the first couple episodes, I just started a list of all the characters.
Yeah.
Because I had to.
You had to.
You had to also.
No. Because I read the books. All right. Let's tuck this in right here. So, hyperbolas look two ways. Hyperbolas either look like this, or hyperbolas, let's look at basketball almost. Hyperbolas look like this. Okay? There is a actual definition of like what they are, like how you get this. And I'm currently forgetting it. Like a circle is all points that are a certain distance away from the center. An ellipse is all points where if you take the two foci and connect them with a line, that line will always be a fixed length as you move it around. Like there's a definition for this. I kind of forget, but I'll explain to you what the equations are for this. Let me differentiate the function from the y and the x-axis.
It's they're formed by the intersection of a plane with two equal cones on opposites of the same vertex.
Yeah, I mean, conics-wise, that makes sense, but like there's something to do with like a focus and like a directrix and all that stuff. Like all of conics, the reason why they call it conics is because if you take two cones that look like this, you can slice through these a million different ways and create a bunch of different shapes. So if you take like imagine a very thin metal blade like a guillotine, and you just slice it through, so it's going to look something like this, and you just slice it through here, what you're going to get is a circle. If and only if you slice this through at parallel to the top and the bottom of the cone. All right, you're going to get a cross section that's a circle. If you come at an angle with the same sheet of metal, you're going to get an ellipse. All right, so that's a different way. If you cut, let's say that you go this way, you're going to get a parabola. And then if this blade instead comes from the top, so it's going to slice through two different cones, you're going to get, let me draw this with a different color, you're going to get a hyperbola.
It's the difference between the distance to each focus.
There you go. Okay, you're going to get a hyperbola. Okay, so the difference between the distance to each focus will always be constant.
You don't really need to know that.
You don't need to know that, exactly, yeah. All right, so two different kinds of hyperbolas. You got a vertical one and you've got a horizontal one. Those aren't really the terms, but I like to call them that. You're going left and right. I mean, sorry, for this one you're going left and right, so just think of that as, horizontal. Here you're going up and down, think of that as vertical. That's just sort of how I put it in my brain. My brain. My sweet, sweet brain. That's kind of weird.
Sweet, sweet brain.
Sweet, sweet brain. All right, so the equations for this. If it's vertical, it's y-oriented. It looks like this. Y squared over a squared. Sorry, I usually put b with the y value. Forget a going there. B squared minus x squared over a squared is equal to 1. For the horizontally oriented one, you instead start with x squared. X squared over a squared minus y squared over b squared is equal to 1. So they're both set equal to 1. They're both subtraction, except one of them starts with the y squared value and one of them starts with the x squared value. I'm going to make both of these centered at the origin, so we're not going to have to worry about scooting the center over, things like that. Don't worry about like x minus 4 squared minus y plus... We're not going to worry about that, all right? If you don't see those things, it's centered at the origin, and that's kind of the easiest way to do this. Okay, so like I said before, there are asymptotes, which are lines that your function does not cross but gets pretty cozy up to. And they're diagonal. They are diagonal. Both kinds of hyperbolas have these asymptotes. All right? And they go through the center. They go through the center of the hyperbola, which in this case is the origin. All right? You have vertices, which is the plural of vertex. And that's these 2 points here and these 2 points here. Okay? Those are your vertices. The way that you draw these things all has to do with your b value and your a value. All right? Essentially, you create a box. So you find your center. We'll put it right there. Okay? This box goes to the right and to the left by a units. A units is the a underneath the x squared. So that's a, and it goes up and down by b. All right, so this is b, and that's b. So the overall dimensions of this box, horizontally, it's 2a, and vertically, it's 2b. 2b, or not 2b? That is the question. Do you know this one, Levi? Whether 'tis nobler
in the mind to suffer the slings and arrows of
outrageous fortune.
Or shoot.
Or shoot?
No.
Okay. Anyway, that's your box. Once you have your box, you can draw your asymptotes. Your asymptotes go through the corners of this box. So whether or not this thing is a vertical hyperbola or a horizontal parabola, you draw your box in the same way, and you draw your diagonal asymptotes through the corners of that box. All right? Lastly, you think, is this thing going to be a horizontal hyperbola or a vertical hyperbola? Okay? If it's horizontal, it comes in from the sides, and it just touches the edge of this box. That's where the vertex is. All right? Same on this side. Goes that way. Goes that way. If it's vertical, instead, you touch this midpoint of the box, and you do this. Like that. Okay? So, let's do one example and then I think we're going to move on. All right, here's the example. It's going to be, let's get rid of some of this. Okay. X squared over 9 minus y squared over 4 is equal to 1. We have our axes right here. The center of this thing is going to be the origin. All right, we don't have any kind of transformations here or translations, so we're going to be fine. Let's talk about our box. Our box, if our a squared is 9 and our b squared is 4, our a is 3, because that's the square root of 9, and our b is 2, because that's the square root of 4. Okay? So our box is going to go left and right by 3 units, and it's going to go up and down by 2 units. So 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. A little bit lower right there. All right? Our box is going to look like this. All right, over 3 units both ways, and then, there we go. That's not the best. There we go. Okay, down and up and down 2 units. That's our box. Now that we have our box, we can draw our diagonal asymptotes. So they're going to go like this. And like that. Okay? Last thing is this a vertical or a horizontal hyperbola? Starts with an x, so it is a horizontal hyperbola. This thing is going left and right. All right? Which means its vertices are going to be on the left and right edges of our box. And then the thing is just going to swoop in, touch that vertex, keep going on its merry way. Over here, swoop in, touch the vertex, keep going on its merry way. And I'm going to draw arrows to show you that the function continues. It doesn't just stop. It goes off into infinity. All right, Kevin Lart, that's hyperbolas.
My turn.
Levi's turn.
Yes.
This is a cool question.
Thank you.
Oh, it got stuck.
It always does.
I think this may. Oh, did you just not have enough?
Yeah.
Okay. I'm done.
You got a probability question?
I do, and I'm pretty sure I'm gonna go about it the right way, but I would like you to double check.
Got it.
Okay. There we go. Oh, I'm so sorry about your head, dude.
It's okay.
Yeah?
Oh, this looks fun.
Yeah. Okay, so here's the question from Alan. I forget who's Alan in chat.
Alan.
Discord Alan is who in chat?
Alan.
Alan, my lord.
Do you remember that? It was like a little animal video.
No.
Okay.
Do you?
No, I don't. I'm just making it up.
Okay,
I don't.
that makes sense. Okay, so this question. I'm gonna make this nice and full screen. We should make a keyboard command for making this full screen. It's probably just F, anyway.
Look at me. I'm a blockhead. What? I was a blockhead.
I know. Oh shoot, dude.
What?
I don't have my markers.
From the set of integers from 1 to 10 inclusive, 2 integers are randomly selected one after the other with replacement. What is the probability that the sum of the 2 integers is greater than 5? There's no question mark.
Okay, so it's probability of sum is greater than 5.
Absolutely.
Yeah? That's what the probability is that we're looking for. I think it would be easier to find 1 minus the probability that the sum is less than or equal to 5, just because there are fewer numbers, but it's really not that much fewer, so maybe I won't do it that way. I won't do it that way. We'll just see how many. So basically, we want to see how many ways are there in total. So let's do that first, because the probability of this thing, we'll go backwards, is the total ways over
Desired.
the desired.
Under.
Under the desired, yes.
This is a cool question.
Yeah, it is very cool. So let's do the total ways first because it's easier. So I'll put that down here. We have total ways. That's going to be equal to, however, we have 2 slots, right? We have this slot, we have this slot.
Slots.
We do replacement. So you have 10 choices for the first one You have 10 choices for the second one. So there are 100 total ways of doing this.
Yay.
Do you agree, Bert?
Absolutely.
You seem to agree.
Yes.
Now, how many ways can we be more than 5? It's not equal to 5, it's more than 5. Well, we know that any number, if we get a 5 or up, we're going to get this, right?
Mm-hmm.
So, there are... Yeah, go ahead.
Well, okay, no. Do you want me to say what I'm thinking?
Yes, because I can think of a brute force way. I don't have necessarily an elegant way to do this.
I think we have to be methodical here.
Okay, so just brute force. Yeah.
If you get 1 with your first number, all the other numbers that could satisfy this to make it greater than 5, you have to get at least a 5 and up.
Mm-hmm.
So if the chances that you get a 1, that's a 1/10 chance. And then the chances that after the 1 you get something that is what?
But then you're doing probability.
This is probability.
No, but that's the probability of this
All right,
happening.
Forget the probability.
We're doing
number of ways.
Yeah.
Okay.
That's all I'm saying.
So you need to get at least a 5. Anything from a 5 up to a 10. Because if it's less than 5, it's a 4. Your sum is going to be 5, and that's not cool. So the number of options we have here
is
6.
6 ways here, because you can get 5, 6, 7, 8, 9, or 10.
Yes.
It's a 1 and then this.
Yes.
So we're not counting the probability of this happening. We're counting the number of ways this can happen.
All right. So I'm going to write 1 gives us 6 ways, and then we're done with 1. So now we can go on to 2.
And if we have 2, then we're going to have 7 ways.
Because now we can have 4 through 10.
4 through 10.
I'm going to write that to the right, actually.
3. Okay, yeah. 3, we have 8 ways. 4, we have 9 ways.
It's about to get great, actually. Because no matter what you do, it's going to be greater than 5.
And then 5 and up, we have 10 ways. Right? Because 5, you have 10 ways. If you get 10, or if you get 7, you have 10 ways. All of those.
2 through 10. And then with 5, you're always going to get it. Yes,
yeah,
you're right.
You can get a 1 through 10.
Yes.
So we have 5, we have 10 ways.
And then with
I'll
the rest
just
of
erase
them.
this.
Yes.
So that means
5, 6, 7, 8, 9, and 10 all have 10 ways.
10 ways. And this is 1 through 10. You want to do that in blue?
Sure.
But this goes for 6, 7, 8, 9, and 10. So this is 5, 6, 7, 8, 9, 10 is 6 times this. 6 times that number, because, so it's 6 times 10, so it's 60. Because all of those numbers. So we have 6 plus 7, 8, 9 plus 60, which will be 13, 20, 130, 90. Wow. So it's going to be, so this is our desired, and this is our total, so it will be 90 divided by 100,
0.9.
which is 0.9.
Look at that.
I feel like it would have been easier to, okay, let's, for the sake of argument, do it backwards.
Yes.
So this is going to be equal to
All the ways that you can't
1
get.
minus p of sum is less than or equal to 5.
Sure.
So if you get a 1,
We can ignore everything
you can ignore
from
that.
5 on.
So if you get a 1, you have, how many ways are you allowed to do it? 2, 3, and that's it.
1, 2,
Oh, 1, 2, and 3.
3, and 4.
So 1, 2, 3. No, you can't. Yes, you can get a 4.
Yes.
And then a 2 on the first draw. You get a 1, 2, 3. You get a 3. You get a 1 or a 2, and a 4. You get.
You're absolutely
a
right.
1.
And that's
Yeah.
10 options right there.
Yeah, these are
So
your
there's
10
a
options.
10% chance you won't get it, which means there's a 90% chance that you will. You were right.
Yeah, that ended. It just seemed like 5 was halfway to 10, so it would. But we're adding, so of course it's not going to be that.
Yeah.
This is fun.
This is fun.
Also, Ben Jr. asked a really cool question.
Really?
It was not in the questions for stream. So I don't know. It's really cool though.
I hope so. Should I erase this?
Yeah, erase that. I'm gonna pull up another one. It's not from questions for stream, but it's from earlier today, and I didn't see it until now.
Oh.
It's okay.
Is it though?
Yeah.
I hope so. Because if it's not, it'll be your head.
Yeah.
Yep. Heads are gonna roll, Levi. Heads are gonna roll. like quarters with heads.
Yeah.
Yeah, they're gonna roll it, and you're gonna see the heads. Anyway, like everything happened in episode 1, you got introduced to the White Walkers.
Did you really?
Yeah, that's the very first scene.
Oh, of course.
Yeah, the guys beyond the wall. You have Daenerys marrying Khal Drogo.
No, she doesn't marry Khal Drogo.
Yeah, she does.
Dude, you sure?
Yes.
Okay, here we go. Let's make this way smaller. This is really cool. Read this question. I'll erase this. Read this question. It's awesome.
All right.
Thanks for the follow, by the way.
Hey!
Ball.
B-ball points,
Oh,
24.
ball point. B-ball point. 24.
Point C is 6 inches from plane M. To the nearest integer, what is the area in square inches of the portion of M that contains all points that are not more than 12 inches from C? Oh!
Yeah.
Interesting.
Yeah, it's very interesting. I'm going to draw it.
So it's going to be a cone, isn't it?
Yeah, it's really cool.
That is quite cool. It's quite cool. It's a bit weird, but it's quite cool.
Yeah?
Yeah.
Hey, B-ball point, do you have any questions? You can put them in our Discord, which is linked down below.
Did you like that, huh? Did you like our Discord?
Yeah?
You wanna put a little question in there? Huh?
Okay, so we have this point C, and it is 6 inches. Let me make this a big 6 inches. 6 inches from this plane.
Nice. No.
What?
I took a class on this. Perspective.
Yeah, it's not how you do it in math, though.
Perspective.
No, I understand the perspective part. Okay, here's plane, what is it, M?
Plane M.
M.
It's just a simple plane.
And then, I didn't make this plane big enough, but they say the portion of... Oh, wait, no, this is not what I thought it was. Oh, the area in square inches of the portion of M that contains all the points that are no more than... Well, it makes a cone, but that's not what we're doing. We're finding the area of a circle. Okay. Yeah.
Inside the cone. The base of the cone.
The base of the cone, yes.
Right.
So what's going to happen is we want all the points that are 12 inches from C on this plane. So this point here is exactly 6 inches from C, and that's the perpendicular distance to this plane. And then we're going to have this point over here that is 12 inches from, or between C and this point on the plane M, we have 12 inches. But then this plane keeps going in this XY direction or whatever it is, XZ direction, whatever you want to say. So there's another point here and another point here and another point here, and this is not quite the right size of plane.
You drop C a little bit. Oh, jeez. If you make C a little bit lower, then 12 will fit.
No, it's not so much that. It's just coming down here with it.
I mean, all of it will be in the plane.
It's all about perspective, Bird.
Yeah.
So we have another one that's 12 inches over here. And then we have all of these points along, I mean, the plane will continue, but all of the points around here. So we're going to get this relatively fat cone on plane M. So these are the 12-inch distances to get to all of the points on plane M that are 12 inches from C. And the question is asking for the area of things that are not more than 12 inches, which is less than or equal to, so it will be the area of this circle. So the area of this circle, we know that this is a distance of 6. So to find the area of a circle, you need the radius r. Do this in another color. So this radius r is going to be, we're going to use Pythagorean theorem because we have 6 and we have 12 for the hyperbola is not the word. Hypotenuse is the word.
Hypotenuse.
So r equals 36, no, let's say 144 minus 36, which is going to be, is this a 30, 60, 90 triangle?
Square root.
Yes. Is this a 30, 60, 90 triangle? Because this is half of that, so this would be 6 rad 3.
I think you're right.
Oh, look at that. So this will be 6 rad 3, but I'll brute force it. So this is going to be the square root of 108, which is r equals the square root of 36 times the square root of 3. So r equals 6 rad 3 inches. And now we need the area. So the area is going to be, well, we're squaring it, so it doesn't matter. Bummer. It's going to be pi times 6 rad 3 squared, and that will be 108 pi.
339.
Sorry?
The answers are in terms of approximate.
Oh, 108 pi, so 339 looks good, yeah. Square inches. Square inches. That's a hard question, but it's cool. Geometric, three-dimensional perception, I think, is what we've defined these question types as. Bird! You sometimes forget you're not a bird, or that you are a bird.
I always forget that.
Yeah, you do. Okay. We can do our own questions, or if you have questions, please ask us. You should ask us.
Yeah, you should definitely ask us.
It got on my head.
Really?
Yes.
You gotta watch out.
Yeah.
That noise spooked me. You should see Levi. He was pretty freaked out.
I was not happy about it.
Yeah. If you hear that noise late in the night, you're probably going to die. I don't know what else would happen after you hear a noise like that. It's probably some headless person who's like a ghost.
Just breathing out of their neck stump.
Yeah, exactly. Yes, that's what I was thinking. Yeah, the air is being sucked down into the stump.
It's just the sound the esophagus makes when not muffled.
Yes. The trachea.
Not the esophagus. What is the
trachea.
epiglottis? Is it the epiglottis
the
that
trachea.
covers it?
The trachea.
No. The trachea is the tube.
Is
But
the
what's
wind
the
tube.
what's the little?
When they say it goes on the wrong tube, they're talking about the trachea. I think it's the
Is the trachea always the wrong tube?
with the radius equals altaipsum.com. No, wait, is it the epiglottis? It's not the larynx, is it?
No, I think it's it might be the larynx.
What is the
little pop, pop.
The uvula is the little punching bag.
Yes.
Oh, that's a fun one to say. Inhaling as well. Uvula. Try it.
I'm not going to try it.
Why?
I don't like it.
Well, what if you did it?
I wouldn't like it.
You don't know that. You just don't like it when I do it. Uvula.
Okay. Since you asked, Alta Ipsum is our sponsor.
Alta Ipsum is literally the best.
It is.
It's so good.
It is so good.
It is literally the best. I can't. What else is there to say besides it's so good?
I think we should explain what it does
All right.
specifically.
It is an application you can download on your smartphone, on your computer, on your Game Boy, on your Tamagotchi, on your Palm Pilot, on your Motorola Razr,
on your BlackBerry
on
Pi.
your BlackBerry Pi, Raspberry Pi. But BlackBerry that's a nice fun little thing. What it does, it lets you plan out your academics. You get to set goals. You get to track your grades. You get to schedule when you're going to study for things, do your homework, write essays, all sorts of things. You can color code things. You can put Nerdish in there.
You can put Nerdish in there. You should. Can we get a download check on your phone?
What does that mean?
Yes, you can get it. Whatever that means, you can have it.
Yeah, just take it. We don't want it.
Yeah, we don't understand
also,
it, so we don't have that
it's
thing.
free for the first month.
It was also free last month, but you missed that month.
How could you not get onto this
We've
deal?
been telling you for
It's
days.
literally free.
Yes.
It costs no money. The
None.
fact that you're not doing it right now, what are you doing?
You're actually paying them.
Hey, the punch down. You're right. That's right. Stay off the beat, CJ. Do not get onto the beat.
Right.
It's a dance move we made up. Should we tell them about
Well,
it?
I told you about it.
That's not true at all.
Okay.
No. It means we can see that you use it on your phone. Oh, us. We don't have cell phones. Yeah. Levi and I are kind of like a little primordial.
Yeah. You also have to be in high school to look at it.
Yeah.
It's just a black screen if you're not in high school. So
Your
it
eyes
wouldn't help us.
There's the post-high school eyes you get, and
Yeah.
you just can't see it.
Yeah.
Stop.
Ow.
Why?
I don't know. I thought we didn't condone violence.
We don't condone violence. We don't. We don't condone violence. We condone Alta Ipsum, but not violence.
Yes. Oh, speaking of condemnation, Tight Bond glue.
Tide Bond Original Wood Glue. The industry standard. Professional strength, interior use, It sands easily. It's short cleanup time. Water cleanup. Net 8 fluid ounces. For those of you interested, that's 237 milliliters. Why don't you read the nutrition facts?
Okay. It is made with glue. Many screaming horses were used in the making of this product. Franklin International from Columbus, Ohio.
No actual gorillas were used in this glue as opposed to Gorilla Glue. Please don't. Why would you do that? Why? He just put glue in my hand. Now I'm going to have this here forever because that's the tightest, most industry standard glue there is.
Okay. They don't pay us a cent. Do you all of you have questions? I know there are questions in there. Just get them out. You need to do some soul searching, okay? And we will answer those questions. It can be math, it can be English, it can be writing, it can be reading, it can be science, it can be other math, it can be other of all of those things. It can be about Brady. I can tell you exactly what makes Brady tick.
It's my heart.
Bird,
What?
you take away all my power when you say things. What I'm gonna say.
Hey, number 7's a fun one.
I don't want to do number 7.
Well,
Reading
that's why
from
I'm gonna do
yesterday.
it. It's change of pace,
No,
man.
but Eric doesn't want to do it. We're gonna do reading.
Well, it doesn't mean Eric doesn't want to do it. It's just Eric also wants to do reading from
Eric
yesterday.
hates number 7. Eric, how do you feel about number 7?
What is reading from yesterday?
the stuff I was doing?
Really?
Yes.
Can I do this really quickly?
I don't ask Eric. Eric's got to tell you.
Eric, do you mind if I do number 7? Oh, there's a question in the Discord.
Yes.
Take a look at it. Is it a good one? Do you like it? Would you buy it?
I would not buy it.
Oh, this is fun. Here, go ahead and put it on.
Papoose. I love the name Papoose.
I bet you hate that name.
Why do you bet that? That's a terrible bet for you.
Oh, expected value. I like this.
Okay.
Do
Bam.
number 7.
Bam.
Is that a smartphone? No, it is not. You saw incorrectly.
It's a smartphone. It's not a cell phone.
Yeah, it's not a cell phone.
Eric, we don't need you
Yes.
asking us these things.
You think we can't handle our own stuff, Eric?
You're right.
It's like you're trying to be our dad or something.
We already
Can they
have.
see it while we're cropping it?
I think so.
Yeah.
Can you see me cropping this? I don't see why you wouldn't.
Can you guys see it right now? Is it blocking me right now?
Okay.
We'll see. All right. Oh, you gotta make it a little bit bigger, man. Or you know, just make the screen bigger. Sorry, make the screen bigger. Full screen it. There we go. Evan and Ron. Okay, cool. Evan and Ron play a game of rock, paper, scissors. Each round has 3 equally likely outcomes for Evan. Win, lose, or tie. Evan earns 2 points for a win, but he earns nothing for a loss or a tie. Let the random variable n represent the total number of points he has after 5 rounds. What is the expected value of n? Good. Expected value. Expected value is related to probability. It's related to it. It's not the same exact thing, but it's related to it.
They're cousins.
If there are rewards and there are costs for certain things happening, a lot of times we like to use expected value. Let me give you an example. Let's say that there's a lottery. And let's say that you have a 1 in 100 shot at winning, and if you win, you get $500. Now, let's say there is a 99 out of 100 chance that you lose, and if you lose $1. Okay? What expected value asks you is, there's only 2 options here. You're either going to win or lose. But if you were to play this game an infinite number of times, over time, what is the average amount of reward you get for each round? And here's how you should think about this. Let's say that we played 100 rounds of this lottery. We did it 100 times. If we did that, we would probably expect to win 1 time and lose 99 times, okay? So if that were to happen, we would win once and we'd get $500. Fantastic. But we would lose 99 times and we'd lose $1 for each of those, okay? So overall, the amount of money we take home would be 500 minus 99, which is equal to $401. And that's after playing 100 games. Let's take that and divide it down to find what the average value we'd get for each game would be. All right? So we take the total reward for 100 games divided by 100 games, and we get $4.01 per game. Okay? Every game, on average, we get $4.01. So you're never going to get that, obviously. You're either going to make $500 or you're going to lose $1. But over time, the expected value of playing this lottery game is going to be positive $4.01. Okay? Now, this isn't exactly the equation for expected value, but it's pretty much what you do. The normal equation for expected value is going to be the probability of event A times the reward. This pink marker is not great.
No.
Times reward of event A plus the probability of B times the reward. Now, reward also could be negative, so it's sort of like the outcome. Reward of B, and it goes on plus ... Depends on how many different outcomes you might have. All right? So for this one, we want to find the probability of each of these things happening. Let's just do one round of rock, paper, scissors. We'll figure out the whole, there's 5 rounds afterward, but we'll start with just one. Oh man, if you don't spray the stuff, this is muscly. Very workouty-able. Okay, so the chances that you win, that's 1/3, because there are 3 different things, equally likely outcomes. So the chances of winning would be 1/3, and the reward of winning is 2 points. All right, so overall that equals 2/3. The chance of tie is also 1/3, but you get 0 points for that. So that's going to turn into 0, and the chance of a loss, you can see where this is going, is 1/3, but you get 0 points for that, which is 0. You add all these up, you're going to get 2/3 of a point per round. Per round, okay? Which means if we're going to play 5 rounds, it's just going to be the expected value of 1 round times 5. So 2/3 times 5 is going to be 10/3, which is J. Very good. All right, Eric also asked to do number 7. I'm not kidding, he actually said that.
Oh, I see it.
Yes.
Oh.
So we'll do number 7, then we'll talk about reading. But who asked this question?
What?
This probability one.
Well, I don't know.
Okay.
Papoose.
Papoose?
It was Kevin.
Kevin Lart?
Hmm.
Got it. Love Lart. Gotta love Lart.
Yeah.
I think. Do you have to? Okay. Kevin Lart. Good. Did that make sense, Kevin Lart? I hope it did. I hope it made sense, Kevin Lart. If not, we could just talk more about hyperbolas. Levi would love that. Gotta let it dry. While it's drying, we're gonna read. Now I gotta make this full screen. All right. 9 to the A power times 3 to the C power is equal to 177,147. 2A plus C would be equal to what? What? All right. I'm going to put this here and here. All right. We'll get there in a sec, guys. Don't worry. Just bear with us like bears do. That's why they call them bears, is they're very good at bearing through things and bearing with things. Like catching salmon at the stream. That's what they bear with. All right, so we do not have the same base here, and that is the tricky part. For instance, if we had 9 squared times 9 to the 3rd power, those would be the same base, which means we could apply our exponent properties, which means add the 2 exponents, we get 9 to the 5th. Unfortunately, we don't have that here. So what we have to do is change one of the numbers into the other number, okay? Which is what we will do. 9 and 3 are very special. There's a connection between them. 9 happens to be 3 squared. So if we rewrite this, 9 to the a times 3 to the c is equal to 1, 7, 7, 1, 4, 7. We're going to rewrite 9 as 3 squared, which is equivalent to 9, so we're allowed to do this, don't worry. Times 3 to the c is equal to that. Exponent properties. If we have exponents on the inside and outside of parentheses, we multiply them together. So we have 3 to the 2a times 3 to the c, and I'm not going to write this number again. Now we have the same base, so we can actually add the exponents. So this is going to be 3 to the 2a plus c is equal to 1, 7, 7, 1, 4, 7. They're asking us for 2a plus c. That is the exponent right here. So 3 to what power gives us that number? All right, you can play around with your calculator, or you can use a logarithm to solve this, all right, which your calculator would then do. So we're going to rearrange this into logarithmic form. This is going to be log base 3 of 177, 147, gives us our exponent, which we're trying to solve for, which is 2a plus c. I will now take out my calculator, and I will perform this log. Where is log? There it is. Okay, log base 3 of 177,147, enter, is 11. 11 is 2a plus c. We don't need to know what a or c is individually, because all they're asking for is what 2a plus c is. So this is going to be 11. All right, Levi, reading time?
Oh gosh, it is reading time.
Isn't there a song? It's called Reading Time?
Reading time.
Time to read the book. So put your not books down.
Yes, but it's gonna take me a sec to bring this up.
So should I do some kind of like song and dance number?
Yeah, probably.
All right. Any song requests?
Oh right, I have to deal with this garbage.
Oh great. Give me a, oh, it's not the black and white version, is it? It's not the transparent version.
No.
Any song requests? I am a jukebox. If I know the song, I will sing it in a very embarrassing way. I'm not afraid to humiliate myself. I've done it before, and I will do it again. And again, and again. But if there are no song requests, then I will not sing anything. Levi is still trying to get this thing set up.
I'm just not excited, that's all.
Why? You're the one that wanted to do reading.
No, Eric wanted to do reading, and I do what the people want, because I'm a public servant. Are you?
And I'm not?
No.
Why is that?
You're a private servant.
How do we do reading? They need to read the passage.
Yeah.
Okay. Weezer, Beverly Hills. All right. Here we go. Ready? Here we go. Someone once told me the grass was much greener on the other side, but I took a visit, and it's possible I missed it. It's different, yet exactly the same. Yeah, yeah, yeah. Beverly Hills, that's where I want to be.
Oh,
Living in Beverly Hills. Wow, 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 wow. Here's the bridge. The truth is, I just don't belong. It's something that you're born into, and I just don't belong.
all right,
No, I
everybody.
don't.
We're almost
I'm
there.
just a no-good, beat-down fool, and I will always be that way. Something, something to something, something. The Beverly Hills. That's where I want to be.
Can you guys see this okay? Is this big enough for you to read?
Was that last math question an ACT question? Yes, it was. They do change it based on the ACT. You got to be ready for that. Got to be ready, Kevin Lart.
Yeah, whatever. Let's just make it fully there.
That's huge,
Okay.
man. You got a little window here.
Oh, yeah. Yeah, but I'm not writing much.
Eric
Okay.
TLT, that first song I sang was a theme song from a show a long time ago called As Told by Ginger, and there's no way that you would know that show, but it was a very lazy theme song. Here we go.
Big enough to see. Very good. Okay. So, this is the reading section. Just so that you know, this is SAT number 8 of those free practice tests they give out. So you can find that link for yourself. We don't have a link below, but just if you Google SAT 8, it is the first link. I'm pretty sure. Okay. So this is the reading section. This is the second passage. I'm pretty sure. Yeah, we're starting the second passage on the right side. Mash. Bird. Mash.
MASH.
Yes. I don't know what that's referencing. Okay. Looking at our questions here, we have the passage primarily serves to do something. So the passage serves to what? That is a purpose question. I don't like purpose questions at the beginning because, first of all, we haven't read this, or you may not have read this passage. I haven't read this passage in a little bit, but I should remember most of the stuff. So we're going to skip question 1, or question whatever this is, 11, because we are not prepared for it yet. We've just assumedly read the passage, and then we got to the questions. Don't do the big idea questions first. Leave those for last. We want to do questions 12 and 13 because they're very clearly simpler questions. I'm not saying they're easy, but they're simpler. You know exactly what's going on. You don't need to know the whole passage. So, and remember, these are vocab and context, so we'll practice these. If you want to sort of ignore me for the first one and then do the second one, whatever. Ignore me for number 12 and do number 13 on your own, as long as you're doing the right approach, which is look at the line number, find a word, and then don't use anything they give you. Come up with your own word based on context, your own word, and then match something to your word. It is the best way to do these questions, I promise. Don't just take the answers and put them in the passage. Okay, line 21, we have the word allows. So let's go up there and figure that out. Okay, so we define tests. I'm going to read from here. We define tests as time-sharing experiments for the social sciences. And then we have tests allows scientists to order up internet-based surveys of a representative sample of U.S. adults to test a particular hypothesis. Okay, so there's a Stanford political economist named Neil, and he's got some grad students. That's exciting, and he was funded by some grants. He was funded by a competitive grants program called TESS. And tell us what TESS is. And then it says, TESS allows us to, so allows. Let's think about how we want to, yes, permits, exactly, permits. Now, the word allow can do some things differently outside of this context. You know, I allow you to come to my house. It's giving us the ability, right? It permits us to do something, but it gives the researchers the ability to do something. That's how we want to use this word. I can't think of anything better than that, so let's go look at the answer choices. We have admits. Admit is different. Admit means you admit guilt. That's one way. It could also mean you admit somebody inside. That's also not quite what we're trying to say. Tolerates. Again, not quite, because tolerate means you accept a different. You're tolerating it. You're being tolerant. That's a little bit too emotional and too human. This is not a human thing that we're saying. TESS is not a human. It's a grants program. Then we have grants and enables. Okay, now this is dangerous. Grants, we were just talking about a grant program, so now that might get a little worrisome to have the word grant in there, because it might work. And then enables. So you like C. Be careful with this one. You are granting something. That means you give the ability to do something, right? Which is very close. Let's go up and see how that works, because I also like enables. So you're not putting all of the answer choices in, but once you narrow it down, see which one. There might be a prepositional issue here. So enables. The grant program TESS enables the researchers to do something, or grants them to do something. So let's read these lines again. We have TESS grants scientists to order up internet-based surveys. Not quite. The word grants there is the direct object is at issue here. So you grant someone the ability to do something, but you enable them to do something. So there's a very fine difference between those two. The correct answer is D here. C is a good second best answer. A and B are definitely both bad, but the spirit of the word is to allow something to happen, right? You said permit. It permits researchers to do something. Grants is giving something rather than letting something happen. So there's a fine line between those two. Enables is a little bit better. You make it possible for them to do that. Okay, let's do the next one, number 13. And now notice, maybe you've read this passage, maybe not, but even if you've skimmed it, we now have gotten a little taste of what's in the passage. We have this program, we have this Stanford researcher researching stuff based on this competitive grants program. So we have a little bit of in-depth stuff by just doing a question. Okay, number 13. We have strength in line 43. So let's ignore the answer choices, go up to line 43. And we might have to do 2 pages worth. So starting on the top right, we have, not unexpectedly, the statistical strength of the findings made a huge difference in whether they were ever published. Okay, so the statistical strength. I would like to define that for ourselves. This whole passage is about null results and whether or not the results actually tell us anything of significance. So statistical strength probably means based on, so statistical blank, something about the statistics of a study will determine whether they're ever published. And we talk about publishing things if they matter, right? The strength of the statistics or the validity of them or something like that. Validity, I'm going to try to think of a better word than validity. The meaningfulness. Yes, dependable. That's good. I like that. Okay, so dependability, meaningfulness, validity, those things, right? How good the statistics are. So now let's look at the answer choices. We have attribution. Okay, fine. I don't even know what statistical attribution would mean. So I can't even tell you how that helps. So let's leave it alone. Maybe we'll have to choose that one, and I'm missing something. B is exertion. No. Exertion is a pretty human thing, and that means how much effort is there, and there's no effort with statistics. That doesn't jive. So I don't like B for sure. Toughness, same thing. Strength is definitely toughness, definitely not in this context, because statistics are not tough. That's silly. And then we have significance. I like significance because we've definitely heard statistical significance before. That's a very common phrase. Maybe you haven't, but it's a very normal thing. So yes, D is the right answer. Attribution, I can't even imagine how you would mean statistical attribution, so that's no good. Good, D. So now we're in this passage a little bit more. We haven't even read it, but we now know about the researchers using tests, competitive grants programs, and then we have here the results of a study, the statistical results or the significance of it is one of the main factors in determining whether or not the study is published or the results are published. Okay, so let's move on. Okay, we have number 14 and 15. I'm actually happy to do this because this is a 2-part question and it's pretty straightforward. It's asking number 14, the passage indicates that a problem with failing to document null results is that. Okay, so this is not an inference question, it's not a purpose question, it's not a main idea question, plus it's a 2-part question. So number 15 is going to have the answer in it, right? The answer to number 14 will be in number 15, so we don't have to look super hard and understand everything on a grand scale. So we know the question is, what does the passage say specifically about a problem with failing to document null results? It's not asking about what is a problem that leads to null results. It's not asking about what is a problem with documenting null results. It's what is a problem with failing to document null results. So we don't document a null result, or generally we don't. What does that cause? What is a problem that causes? That's what we have to keep in mind. So 38 through 40. Also, I understand this is possibly mind-numbingly boring, but it is a very, very important skill to have to be able to identify exactly what you're being asked, especially on the SAT. This is much more important than many other things because the SAT asks very confusing, nitpicky questions. Be nitpicky right back, and this becomes a little bit less tedious because you're not saying, okay, I just don't know what's going on. You're very specifically looking for problems in answer choices. So I didn't even look at the line numbers yet. 38 through 40. Okay. We have, their answers suggest to Malhotra that rescuing findings from the file drawer will require a shift in expectations. I don't see how that relates to, or it does not talk about a problem with not documenting null results. This might be talking about looking up old null results that were not documented, but this is not a problem with it. A shift in expectations is not a problem. I don't like this. So A in number 14 is wrong, which is great. So we got rid of A because it's just irrelevant. That's hopefully what you can do with 3 of these. Probably not what's going to happen though. 48 through 50. Let's do that. We have, however, the Stanford team was surprised that researchers didn't even write up 65% of experiments that yielded a null finding. Okay, this is one of those dangerous answer choices. It's talking about null finding, it's talking about not documenting it, and it's talking about people's reaction to it, but it is not a negative result of not documenting those null findings. Therefore, it's wrong. It can't help us answer the question. So B in number 14 is wrong. 56 through 59. We have, he and others note that the bias against null studies can waste time and money when researchers devise new studies replicating strategies already found to be ineffective. Okay, so a bias against null studies, that could line up with the question of saying not documenting null results, so that's okay. It can waste time and money. Wasting time and money is a problem, for sure, when researchers devise new studies replicating strategies already used. That makes sense to me. They're saying that, oh, we did this study, but we didn't report the findings because it didn't give us good results. And then other researchers spend time and money doing similar things because they don't know that study was already done. I like C a lot. So again, we're not choosing it because we have to do D, then we'll come back to answer, and we're not even answering the question. We just have decided, or I've decided, and I hope you'd agree with me, that C could answer our question. D, 59 to 62, we have, worse, if researchers publish significant results from similar experiments in the future, they could look stronger than they should because the earlier null studies are ignored. Okay, that's interesting, because that seems to answer the question as well. We have, well, it says worse, so it's talking about a problem again, but it's a worse problem. If researchers publish significant results from similar experiments in the future, they could look stronger than they should because earlier null studies are ignored. So that's another problem. I'm not sure yet, so we're going to have to look at the answer choices for 13. Because honestly, C and D, unless I'm missing something, which I may be, C and D both seem like they answer the question. If not written, they are not further referenced. What are you talking about? Is that line numbers? Did I miss line numbers? Like choose the line numbers? Not sure what you're saying, but either explain it or not, up to you. Okay, so we have here now we're looking at number 14 and seeing what supports it. So the results of related studies will be misleading. I think that lines up, A in 13 lines up with D in 14, right? Because it's misleading because we give strength to other studies more than they should get. So that's a misleading thing. I like A. A and D might work. Then we have B, researchers may overlook promising areas of study. No, that sort of sounds like the opposite of C, so I don't like that. And then C in number 14, we have mistakes in the collection of null results may be overlooked. That's a negative, as they are not referenced later on if not written, so that one also works for 15. Right. You're saying that A, that's a negative as they are not referenced later on if not written, so that one also works for 15. So that one will also work. Okay, yeah, I see what you're saying. Okay. I don't like C in number 14 because it says mistakes in the collection of null results may be overlooked. D in number 15 is talking about overlooking null results, but but C in 14 is saying mistakes in the collection of null results. So that's no good. I don't like that one because that's a little bit of a jumble. It's saying mistakes in the collection of it, not them itself. I'm not sure exactly what would be going on there. So I don't like C. Mistakes is a bad word. Then we have D. The bias against null results will be disregarded. This is another jumble. We are disregarding null results. We're talking about that, but that is what's supposed. The question is, what does that cause? What problem does that cause? And this is also jumbled anyway because it's saying the bias against null. We're now disregarding the bias against null results. We're not disregarding null results. So these are the jumble. It's very, very small differences where it's just. This is talking about disregarding the bias against something, not disregarding the thing itself. That is an incredibly important difference, and that level of specificity is something that you must be able to identify. So I don't like D, I don't like C, and I don't like B. So A is the right answer in 14. And now to your, so then we're looking at C and D in 15. So Eric, I don't like B in number 14 because researchers may overlook promising areas of study. It's not that they're overlooking them. That's not a problem that we've talked about. We've talked about researchers redoing stuff that they shouldn't have been redoing and wasting time and money. We've also talked about researchers giving too much credence to results that also have gotten null results at some point too. So again, we're not missing an area of study. That's not supported. So I don't like B in 14. I think A in 14 is correct. The results of related studies will be misleading. And then we have C and D. So let's go back up and just look at that. We are trying to say that the results of related studies will be misleading. This is where, again, it's getting extra nitpicky. We have he and others note that the bias against null results can waste time and money when researchers devise new studies replicating strategies already found to be ineffective. You could make a couple of assumptions to get from that to results can be misleading. But that assumption is literally what we say in lines 59 to 62 or whatever it was. Whereas if researchers would publish significant results, then they could look stronger. That's where it's actually the exact support for answer choice A in 14. So I think the answer would be A and D. Do you have any questions on that? I think we're going to hop back to math after this because I think we lost a bunch of viewers for me doing a lot of reading questions, which is totally valid. So Eric, do you have any, or anybody else, do you have any questions about the approach to this type of question, the two-part question, or doing the simpler ones first, the vocab and context? Just do those first. It makes it easier. No questions. Great. Okay. So I'm going to take this overlay off. That was a lot. I'm very aware that was a lot. Let's see if F works here. No, it doesn't. Great. So, reading section, we just did, I'm going to talk about that and just wrap it up in a second, but Anybody have questions? Put them in the Discord. Bird, are there any Discord questions?
I will check.
I see. No Discord questions. Okay. Any tone or mood questions on the SAT? Yes, there are. They generally aren't that difficult. But again, those are questions that you want to skip first because they require a very big general understanding of the passage, which you can improve as you, what was I going to say? As you do the more basic, small, low-level questions. Fix that thing real quick. Okay, Bird, do you have any more overlay questions?
There's plenty of them. Let's look for a fun one.
Okay. Oh, okay.
All right. So
You got that? Want me to stay on stage?
let's see.
So should I read the passages or not? It depends. I think if you're a very, very slow reader, we can talk about some ways to not read the entire passage word for word for word. If reading is not a slow thing for you, then yes, read the whole passage. You could also, you want to explain that actually?
I like reading the whole passage. I mean, Eric, have you taken it yet? Has Eric taken it?
No, I forget.
You should do a reading passage. Just print one out from online, or you know what? We have a diagnostic you can take on our website. See what the timing is like, because I generally get the gist of it from reading it. Levi is more of like a skim and pick small sections to read kind of guy. Yawn. Oh, God. I tend to find myself reading a whole passage and then forgetting everything. Interesting. Interesting. Do you find the passages boring? Because if so, that would be a reason why you forget things, because you're not really interested in the first place. If that is a problem, then Levi's got some advice for you.
Yeah, you want me to talk about that now?
Yeah, sure.
Okay.
My advice for you is pretend that you're someone who doesn't find it boring. Go ahead, Levi.
That's terrible advice, Bird.
Yeah, okay.
Okay, I'm just gonna put this up. Okay. I'll just do this real quick. So, Eric, let's go. I'm gonna just go to the next passage. So here's a passage. If you're getting bored with these, especially with the science ones, that's what people find very boring oftentimes. You're going to want to deal with skimming in a very specific way. You are trying to build up your understanding of what and where they're saying things, because the questions tell you where to go about half the time, right? The vocab and context tells you the line numbers. The two-part questions give you the evidence line. They give you exactly where to go. You don't have to look anywhere else in the passage. Many of the purpose questions say, what is the purpose of this paragraph? You know where to go. You don't have to be hunting for things. The ACT, you have to hunt for answer choice. You have to hunt for where to go a lot. But with this, what you can do is read that little blurb at the top. It'll tell you some information. It'll tell you what type of passage you're dealing with, if it's the story time prose one, or if it's the sciencey one or the history one, or whatever it is. So this passage is adapted from Rachel Ehrenberg, Salt Stretches in Nano World. Oh boy. The nano world is the world observed on a scale 1/1000th that of ordinary human experience. Okay, so this is probably going to be science. So with that in mind, you know that this is not going to be a nice flowing narrative type piece where you can follow along nicely and understand the story time. It's not that. It's science, okay? So you are not... This is where a lot of people start losing focus and getting very unhappy when they're in the reading section, because they will be reading this stuff and it's all this new information. It's like reading the science section on the ACT. Don't do it, because it's too much new information and you're not going to actually be able to internalize it. So you want to read until you understand what they're talking about. You guess for about how long they're going to talk about it, skip all of it, and go to the next part. And if you want, you can write in the margin, you can underline or circle important words. I like circling because it's quicker and you can see it more easily when you're glancing over it again later. So this is how we're going to do it. We're going to start reading until we know what's going on and then skip. Because you are used to reading. How long does the SAT take? The reading section you have, there are 52 questions. The reading section on the SAT is 65 minutes, right?
Correct.
Yeah, 65 minutes. So you have what I always need to redo this math in my head. You have 65 minutes for 4 passages and all their questions. So per passage, roughly, you have 15 and a half minutes. No, what am I saying? 16 minutes, roughly, right? Yeah, 16 minutes per passage. So it's about, read the passage in 3-4 minutes, and then you have a minute per question. It is enough time if you're a quick reader. If you're not, it might not be. It's not quite enough time for me to feel comfortable, personally. Do you want the entire SAT? The entire SAT is a little more than 3 hours. Okay, so I'm going to read this and show you how to be able to hop through the passage quickly. You're not getting all of the information that's in it, but you don't need to because you're always given where to go for that information anyway. So, inflexible old salt becomes a softie in the nano world. Okay, so we know we're talking about not normal world, but nano world when we're really looking at very, very small things. Also, this immediately, it says that salt is a softie. So this is going to be a very metaphorical essay right off the bat. It might be a little bit playful. So we know that off the bat. Inflexible old salt becomes a softie in the nano world, stretching like taffy to more than twice its length, researchers report. The findings may lead to new approaches for making nanowires. Okay, so this is what it could lead to. We could do these things with it. Great. The work also suggests that these other things could happen. Okay, and then we go to somebody talk. So I skipped the second half of that paragraph. Alan, thank you for the follow. We appreciate it, and we hope you appreciate us. Okay, we think nanowires are special to go to great lengths to. We think nanowires are special and go to great lengths to make them, said this person. Maybe they are more common than we think. Okay, sure, whatever. Metals such as gold or lead. So now we're moving on, right? We talked about nanowires and salt for whatever reason. There's a connection there. And salt is bendy. Interesting.
I have a child.
Okay. Very good. Oh, yeah, almost done. Then we're going to line 14. Metals such as gold or lead in which bonding angles are loosey-goosey can stretch out at temperatures well below their melting points. But scientists don't expect this super... Okay. Whatever. This is unusual behavior that highlights that different forces rule in the nano world, says whoever this is. Forget about gravity, sure. Okay, so there are differences in the nano world. That's basically all we've gotten, plus salt is something important. Moore and his colleagues discovered salt's stretchiness accidentally when they were doing this other thing. Great. So again, we are very used to how the English language is set up and how these sentences go. So with this one, Moore and his colleagues discovered salt's stretchiness accidentally. They were investigating how this happened. They're going to talk about how they discovered it. But now you know exactly where to go to find out how they discovered it. So if you ever need to know that information, you know it's going to be in this paragraph. You go back to it for the first time. So you're reading only what you need to know to understand what is being talked about generally and where those things are discussed more specifically. You don't have to know all of the ins and outs before you go to the questions. You can do that on a per question basis. Okay. And yeah, this whole paragraph, when the tip was far away, there was no measured force, but within about 7. Yeah, so it's more scientific jargon that you don't want to, don't bog yourself down with that stuff. Okay, moving on. The initial attraction between the tip and salt might be due to electrostatic forces, perhaps good old whatever, sure. That's what they speculate. Okay, several mechanisms might lead to elasticity. Here are some ways it could happen. Surface tension is strong. Okay, wonderful. This bizarre behavior is actually mirrored in the macro world, the researchers say. Huge underground deposits of salt can bend like plastic. Whatever, keep going. Sodium chloride is everywhere, in the air, in our bodies. Okay, sure, we have salt in our bodies. This may change our view of things, of what's happening at the nanoscale. Okay, sure. And then maybe at the end, read that full paragraph. The work also suggests new techniques for making nanowires, which are often created through nano-imprint. Okay, maybe not. Last sentence, maybe instead of stamping nanowires, we should be nano-pulling them. Okay, so this is what I got from that passage. Salt is important, it bends, and nanowires are important to do stuff with. Gold and lead maybe are stretchy, and things are very different on the nano level, but also we can see it on the macro level. Now we go to the questions. So obviously that took, and then we have some graphs and stuff, which we're not reading at first. There's no need to. Okay, now we skimmed that. Obviously, you would be able to skim that way faster than I just did because I was talking. Number 22, we're going to skip that for sure because it says one central idea of the passage. You might be able to do it. You'll have a better chance at doing it if you've really read the passage, but we haven't really read the passage, and there's no point in doing the big idea questions first. You can do them last. So skip that one. Then we have which choice best describes the overall structure of the passage. Again, its overall structure, I don't like that so much. Too big. 24 is not the second part of a two-part question with 23, because if you notice, it actually gives you a thing. So this is just evidence. It's basically you don't have the first part of the two-part question. Which choice provides the best evidence for the claim that Moore's group was surprised to observe salt stretching? This is where I would start. Maybe you could start with number 25 because it's just vocab and context. It's even simpler. But we can start at 24 because it tells us where to go, and it's asking about, it wants evidence for the claim that Moore's group was surprised. That's really, really straightforward, and it tells you where to go. You start there, so you do 24, you do 25, and then you move on. So this way of reading, of skimming, it's not exactly skimming because you're skimming and then diving in and understanding what's going on, and then as soon as you get it and you say, oh, I know where they're going, I know they're about to tell me this story or explain this thing, then you skip it. You could maybe look for words that seem important, but then you're skipping 2, 3, 4 lines at a time, so you're not reading everything. In high school, you're used to reading things and then being asked general questions or very specific questions on it. You have to produce stuff. On the SAT, you're not producing anything. They give you the questions, they give you the passage, they give you the answers. So you don't have to understand everything. You need to understand the structure of this passage, then go to the questions, build up your understanding of what's going on through the questions, the simple ones first, then go to the more complicated ones. It becomes a much more logical way of doing the reading section, and it makes it much less tedious and allows you to be focused a little bit more. Because it's really hard to focus on this passage. If you don't care about nanowires and gold and lead, and I mean, sort of why would you? At least personally, I don't care, because I'm never going to actually think about that stuff. So you make it a very logical approach of, oh, I see what they're talking about. Great, and I see what they're talking about here. Great, and keep going. I have talked enough about this. Do you have any questions, Eric or anybody else, about this approach? You don't have to skim things. If you can read fully, great. Just if you find yourself losing focus because what you're reading is too scientific or something, then skip it. Just make sure, regardless of what you're doing, when you go through the passage, you should be building a mental map of where they talk about what, so you can understand the structure. Okay, great. I'm going to take this off. Okay. Can we do 25? Oh, sure. Yeah, that'll be the last thing we do. So 25. 25 was the vocab. Okay, rule in line 20. So let's go up to line 20. This unusual behavior highlights that different forces rule the nano world, says theoretical physics, whatever. Okay, so this is what I was saying before. I think, so it's saying rule the nano world. We've heard rule the world before, but that's not what's going on, right? It's different forces, right? 20, line 20. Yeah, so this unusual behavior highlights that different forces rule the nano world. So I would think that this, Eric, what do you think could go here? Instead of rule the nano world, what different forces what is their verb? What verb do they do to the nano world? And I'm going to keep reading also. So this person says, forget about gravity. It plays no role, he says. Surface tension and electrostatic forces are much more important at this scale. Okay, so if you're clueless, don't worry about that. You're going to be looking at the context. If you're uncomfortable with the phrase rule the nano world, it doesn't make any sense to you, fine. But remember, they define the nano world as a billionth scale. So at this very, very small scale, when you're looking at very, very small things, what we say different forces do something, do some verb to that world. And then they go on and make it clear, right? That's what this researcher said, and then we have a quote from the researcher. Forget about gravity. It plays no role. So you know that on a normal level, on a normal scale, like us as people-sized scale, Earth-sized scales, gravity plays a role, right? But here, it's saying forget about gravity. It doesn't play a role in the nano world, okay? Gravity is a force. Surface tension and electrostatic forces are much more important at this scale. So it's saying gravity doesn't really do much in the nano world, but electrostatic forces and surface tension do a lot. So those are the different forces that act on the nano world. So I would think, and let me know if this is just totally out of left field for you, but this is have an effect on. They have an impact, right? Gravity plays no role. So we're saying other forces play a role in this world. Those are the things that change stuff. Those are the rules that we got to play by. So if we're going to the answer choices, we have mark. Do these forces mark the nano world? I don't know why you would want to say that. We're not marking things. We're talking about control, ruling it, right? We're ruling that world. We are controlling the world. We're having an effect on the world. So I don't like mark. Oh, we have control. Okay, so there you go. That might help. Control seems pretty good. Yeah, you like B. C, declare. No, we're not declaring things. That doesn't make sense. And restrain. Restrain is okay. It's not bad. It's definitely better than A and C, but control makes more sense. These forces control the world. They don't restrain the world. Restraining is again, a little bit more human. Although in this passage, it's very personified, I think. It's very playful with its metaphorical descriptions of things. So if you don't know the word in the sentence, or why they use that word, that's fine. You know it's a verb in this case. So what do these things do to these things? And then they go on later in the paragraph and give examples of that happening. So that relationship is going to be explained before or after. It might be contrasted before or after. That is what you're looking for. That's why it's a vocab and context question. Okay. Any last minute questions from anybody that are quick, ideally? Just like things that you're thinking about. Any last little things you want to ask? Otherwise, I'm going to head out and see you all next week. Up to you. Ooh. Okay. Seems like everything's fine, so I'm going to head out. But have a lovely weekend, everybody. Study up. Bring your questions next time. We obviously... Yeah, see you on Tuesday. If you don't have questions, you come here to just see what's going on. That's cool. But what we can do to help the most is if you're studying on your own and then you run into roadblocks that you can't figure out with written explanations and things like that, and then you send us the questions on Discord here. And then we go through them and you can ask questions right away. Online classroom type of deal. Yeah? Okay. Have a good night. See you next week.